Hey guys, and welcome to the fourth part of the uFrame tutorial. In this part we're going to start to develop the prototype for our game. We will create things like movement and firing. We will also learn how to generate enemies based on the collections. And along the way I will share a few tips and tricks with you. So let's get started. I have cleared my diagram along with all the files I have modified in the previous tutorials. So we will start from scratch, and as I make those tutorials I learn along with you guys, so I will fix a few things in our diagram which otherwise may cause problems and inconsistency. Here on the platform we got this move command, which corresponds to the intention of the player to move left or right, but how are we going to express his will to stop? For now, let's do the following. Let's create the enum called platform direction. And the reason I give it such a scary name is that if I just call it, direction or move direction, it may cause conflicts with other plugins which have enums with the same name or in classes with the same name. Because, the enum will be generated with no namespace, so it will be like a global object, but of course here I won't get any problems, but always think about the future of your game. So now let's add left, right, and known to our enum. Left, right, and known. Finally, let's make the move command carry this enum as a parameter. Cool. What's next? The good thing about uFrame is that it allows you to start development from any point. And it also provides us with some sort of debug helpers. So let's design the platform view. Here I got the platform prefab. Oops. So let's drag this one onto the scene. And also let's create a quad which will represent the ground. Pay attention to the collider because we're working with 2D physics. That's why we don't need the mesh collider, but the box 2D collider. Now, if we launch our game, we can see that our platform is on the ground. Now let's play a bit with the wheels and apply some motor force. Woo! Well, it's actually moving, so we're good to go. Let's add platform view and switch to the code. Sorry for this delay. Now, as we can see, we got no bindings, but the idea is to use the speed parameter of the platform to apply it to the motors. So let's add a binding to the platform view. Now, if we reload, we can see the binding generated for us. We got a couple of wheel joints, so just in case we will add a few more wheels, let's create a wheel joint 2D array as a public variable. And also let's create private cache of the motors. And let me explain why I do this. Every time we got some wheel, we can access its motor, but if we change the speed, we have to reassign this motor to the wheel. So that's why we can do something like this. For each index in the wheels array, we can take the motor under the same index and set its speed to value. and then take the wheel under the same index and assign newly adjusted motor to this wheel. But we also have to initially cache the motors. So let's use a wake method for this, and pay attention and keep the base invocation here. First, we need to initialize the motors array. And we're going to have the same amount of motors as the amount of wheels we have. Now for each wheel, we need to extract the motor into the motors cache array. Just like this. If you kinda used to link or something, you can use this one, of course. And if you develop for iOS and you want to avoid allocations, I recommend you to take a look at Smooth Foundations, where you can find S-Link, an allocation-free alternative to link. And the overall cool feature about the for loops instead of for each is that you don't get any allocations. So when you develop for iOS, you won't, or you will get less spikes related to garbage collection. Now in my scene, I got the view of the platform on the platform base, which is not kind of what I want really, because you know, I want this object to be the control one, if you will. So I will remove view from here and place it on the root object. But now we got a sort of problem here, because we want to assign wheels, but all the wheels are on this object and I cannot have them all in the same inspector. That's why I will lock this one, create a new inspector window, place it right here, and now if I choose the platform root object, I have my array right here and wheels right here, so I can just drop them and get rid of this one. Finally, I want to initialize my model just to be sure it's initialized actually. Now if I hit play, I can see that my speed actually affects the platform movement, which is exactly what we want. So every time you develop a view object without a controller, you can directly adjust the view model in the inspector, and this is awesome. Now it's time to make our view handle keyboard strokes and transform those into player's intention to move somewhere. And when I say transform, I mean that it is the responsibility of the view to apply some simple logic and solve different problems like control conflicts. You will see it now, and I'm going to keep my code very straightforward, without any fancy features, so it should be very clear to you. Let's use classic approach and handle our keys in the update method. We'll define a few booleans which will represent the current states of the keys. We're going to use A for left and D for right. And there we go. We got booleans which hold information about current state of the key, and they tell us if this one is up or down or hold. We're only going to send commands every time player intention actually changes. That's why we're going to use down and up events for each of the keys. Now when I think of it, let us rename those booleans to actually represent the event corresponding to the key. Nice. Now it looks much more enjoyable as to me. And pay attention now, because this part may be a bit tricky. Every time right key is pressed, we're going to execute move command. But if the left key is held at the same time, we're going to express our intention to move nowhere, because right key and left key balance each other. This may be arguable, but this is the most logical approach to me. In case left key is not held, then we're actually going to move right. When right key is released and the left key is held at the same time, that means that right key is not pressed and it's not held, then we should move left because left key is held. Makes sense as to me. In case none of the keys is held, then we're not going to move anywhere. And the same applies for the left key events. So yeah, if a left key is pressed but right key is held, we're going nowhere because they balance each other out again. If right key is not held, we're going to move left as it corresponds to the key press. If left key is released, then we're going right if the right key is held, because this one is the only one which is in action right now. In case no keys are pressed, then we move nowhere. So yeah, we're only going to execute move command if some event actually occurs with our keyboard, and this is how Vue transforms the intention of the player and applies some logic to decode what's going on actually. And of course you can minimize this. I'm just you know, trying to keep things as clear and as straightforward as possible, because this logic may be a bit tricky. Finally, let's place a little workaround here. When we actually apply the speed value to the motors, we should make it inverted. In that case, things align appropriately and your platform moves left and right corresponding to the key directions. Looks sweet. Now let's design the platform controller. You already know that we got this little handy method called move, which we can override and apply our logic here. And in case you have your parameter here called arg, you may want to rename it to something sensible. Now let's generate a switch construction. And we can apply our logic here. We got the source of our command, the platform view model here, and we can modify the speed like we want. Oops. Let's test this. When I press A, our platform is moving to the left. When I press right, our platform is moving to the right. This is amazing. If I press both, it stops. If I release, it keeps moving. in the right direction. Well, this is some sort of responsive controls, if you will. Now it's time to make our platform fire. That's why I got this rocket prefab, or a bullet prefab, and this will represent the projectile which is launched from the platform. I got the circle collider here, and I'm going to make this trigger. Also, I've added rigid body to my ground, which is represented with this quad, and I made it kinematic so it won't move. Also, I got a script called rocket prepared, and let's design this one really quick. I will just paste some code here. We got speed float property or variable. We also got a transform cache. This is because we're going to use transform in the update method. If you just use pure transport, it will involve get component transform under the hood, which is kind of slow because, you know, it's internal Unity stuff and we can't optimize this. And yeah, it's known to be slow. That's why we're using cache, which is used in the start method as well to initialize itself with transform. Finally, I got this on trigger enter 2D handler, which will just destroy the rocket. Now we hit play, we can adjust the speed of the rocket, and the direction corresponds to the up vector. And when it hits something which is rigid body, it is going to be destroyed. Currently we have a couple of commands which our view can send every time player is willing to start fire or stop fire, but the actual bullet instantiation is going to be in the view. So how do we report this stuff to the view? We can create another property here called fire state and create a corresponding enum. We can fill this with something like firing or idle. And link our property to the enum. Finally, we can add a binding to the platform view. So let's update our view code to use this kind of features. First, I'm going to extract all this stuff into another method, which I will call calculate move or calculate movement. And this one is going to be invoked in my update method. Now I'm going to create a private method which is going to be a coroutine and will return a numerator. Here I will launch rockets and wait for the time which corresponds to the fire rate of the platform. I will explain all this stuff in a second, But right now, let me utilize my binding and generate a switch label for the state. And here, every time I start firing, actually, I'm going to start a coroutine called fire. Every time the state is changed to idle, I'm going to stop it. So look at this. Every time fire state property gets changed, I make a decision. If I'm in the firing state, I'm going to start a coroutine called fire. And every time I change back to idle, I'm going to stop this coroutine. Here in the fire, I got stuff which is not that much related to our problem domain, so that's why we do it here in the view. And I'm going to infinitely launch rockets and wait for the time which is mentioned in the platform.fireRate property. So I got this little handy method, launch rocket generated, which will handle all the stuff we can come up with while instantiating the rocket itself, and picking up the right direction, maybe turning off the collision with the platform itself. We will see in a second. Right now, let's get back to update method. I'm going to need a few states of the space button because I'm going to use it as my firing button. And I will tweak the names a bit. Now every time I got my space key pressed, I'm going to execute start fire. And every time I got my space key released, I'm going to execute stop fire. Let me extract this to another method called calculate firing. And as you see, I have replaced this not implemented exception here with the debug.logFired, so we can test things. If we go back to scene, we can see we got fire rate here. Let's set it to 3, or let's set it to 1 second. And the initial fire state should be idle. Pay attention to this. Now, if I press space, nothing happens because we haven't designed our controller yet, but nothing stops us from testing stuff. We can just change firing, and we can see that fire method or fire message is being sent to us every second because the state is firing. If I switch this to idle, it stops producing those messages. So everything works as expected. Time to upgrade our controller, and we'll make it handle 2 commands: start fire and stop fire. In this game, we don't have any logic related to how we are firing or how fire bullets are calculated because we haven't introduced any kind of, ammo parameter or something. So that's why this is going to be extremely simple. I'm going to just set the state to the corresponding value. For start fire, I'm going to start firing. For stop fire, I'm going to stop firing and set the state to idle. Now if I go back to the game, if I open the console, every time I hold the space, we can see that our fire state changes to firing. If I release space, it is set to idle and the messages don't come again. So awesome. Our final step is to actually produce the bullets every time we fire. And as you can see, I got this gun point which is aligned with the platform base, and it's located right here, aligned with the visual gun of the platform. I will also need the prefab of the rocket. Let me apply the settings we made on this one, and let me set the speed to 3 or to 4. It's the initial speed, but we can adjust it when we, instantiate the rocket. Here in the platform view, I'm going to introduce a few variables. Game object rocket prefab and transform gunpoint. In the launch rocket, I'm going to first instantiate the rocket itself. And as you can see, I'm not using any stuff like instantiate view or something. This is because rocket is a part of the environment and it's not included in our problem domain, and thus it's not included in the diagram. It doesn't have a corresponding view model or something. It's not handled by the uFrame at all. And this is exactly what we want from our setup. Now, let's take the transform of the rocket and set its up vector to align with the gun point up vector. Finally, let's also synchronize the positions. We can also, set up position right here in the constructor. So let's do this and set rotation to quaternion identity. Finally, let's set the prefab. And set up the gun point and hit play. Well, it's not kinda perfect, but as we increase the speed of the rocket, it will look a little bit more natural. And actually, let me set the gun point so it's right here. And it keeps firing, but currently we have one little problem. If I tap the space button, it produces a lot of fires and does not, rely on any kind of fire rate. So we're going to fix this. The reason for this bug is that when starting the fire coroutine, we don't check for any kind of timer related to fire rate. But the global reason for this is that our problem domain gives us this kind of data like fire rate, but it doesn't directly solve the problem. Instead, it delegates it to the view. Of course, we can change the architecture so we could handle logic in the controller and, calculate the fire rate there and have the timer there. But for now, let's stay constant with our decisions and fix this bug right here in the view. First, let us introduce the timer. Which is going to be float and named fire rate timer. This one is going to be 0 in the beginning. Then, with each update method, we're going to check if this fire rate timer is greater than 0. If so, we're going to subtract delta time. Finally, in our fire method or fire coroutine, before actually launching the rocket, we're going to make sure our timer is 0. Then we're going to launch the rocket, and finally set the timer to platform dot fire rate. And yeah, of course we should do while instead of if. Now let's see if it works. Our platform keeps firing while we hold the space button. It stops firing when we release the space button. And finally, it does not produce redundant rockets. So yeah, basically it works. We get a nice moving and firing platform, which is awesome, and we should be proud of ourselves really. So let's have a little rest and tweak our scene a bit, fix the camera and prepare it for the enemies. I'm going to make sure that camera follow object is in the right place, so I'm going to set the X coordinate to 0 and adjust the height a bit. Then I'm going to drop smooth follow script to the camera, set up its target to camera follow object, set height to 0 and damping to 200. Finally, I'm going to set the camera orthographic size to something bigger. And you see our camera gets a bit lifted, but I'm not entirely sure. This looks funny and may be considered a feature. Let's leave it for now and see how this will work when we actually add enemies. Let me change the background color to black. And set the material of this guy here to something cool. Oh crap, I was doing it in the play mode. Never mind. Well, for now it looks much more stylish, I guess. Even though this line is a bit, you know, is a bit small or a bit thin, this is because the material itself is represented with this line. But yeah, let's leave it for now. Just like with the platform itself, we're going to start designing our enemy with the view. So let's drop the enemy prefab to the scene. And give it the enemy view script. The first thing that we really want to do is to handle the collision with the bullet, since enemy doesn't do anything special like moving or firing. Well, of course it's going to move, but this is something different from the platform and will not require as much coding as the platform itself. Our enemy is going to have a rigid body set to kinematic, and it will also have a collider, but it will be set to as trigger. So we're going to introduce a handler for on trigger enter 2D, and it will receive a collider of the object which is actually in the trigger area. So this simple piece of logic basically says that if the object which collided with the enemy is a bullet, then we're going to execute hit. Also, in the enemy controller, we've already got this stuff which I forgot to clear, but now it will come in handy since it just sets our enemy state, enemy is dead, to true, which is exactly what we want. So let's see how it will work. Oh, yeah, we should add a rigid body. Set the kinematic and box collider 2D, I guess. I'll align this one a bit. And set it to trigger. Let me remove this extra bullet we have right here. And you can debug the enemy using his view. So now if I fire, his state is changed to dead, which is exactly what we want. Our final step in this part is to make the enemy disappear every time his view model property is dead is set to false. So we need to visit the designer to introduce the binding. Now here we can use the value, and if this one is true, then we do destroy game object. But as you have seen, our bullet is not being destroyed when we hit the enemy. This is because his game object is being destroyed right away, and the collision on the trigger on the rocket itself does not work. To fix this, let's add this little workaround here and destroy his game object after 100 milliseconds. Now it works. Now, when we have a single enemy working properly, let's see how we can create a lot of enemies based on our game view model. If you remember, we have this information like enemy rows and enemy columns which say how many enemies we want to generate. Let's navigate to the Pinky Island's game controller. And as you remember, we have no commands, but how about introducing start the game command? Now we have this little start the game method. What we're going to do is we're going to add as many enemies as we have told in the view model. So we're going to create a new enemy using the enemy constructor. and we have this one injected because Pinky Alien's game is directly connected with the enemy. And we're going to add this enemy into the collection. At this point, our enemy view models are added to the collection of the corresponding Pinky Alien's game view model. But it doesn't mean that those will be actually displayed on the screen, since it doesn't imply that the views will be generated. Let's see how we can generate the views based on the collection events. And yeah, you're going to use this a lot, so pay attention to this part. If you look at our Pinky Alien's game bindings, you will see we got a few things available, and some of them relate directly to the enemies collection. Events like added and removed are here to help you do additional stuff when the enemy is being generated. I mean, the enemy view is being generated. And by default, uFrame utilizes generated code to actually create the enemy view for you. But if you want to, create the view yourself and do some additional stuff, you can also add create enemy view binding, so that you will be able to return appropriate view of the enemy, just in case you want to be more creative about how you create this view, and maybe you will choose from a lot of prefabs or do any kind of stuff you want. For now, let's add both bindings and see how those work and what's going on when we don't actually use them. Hit save and compile, and bingo, we got a few bindings generated. This one, enemies added, is invoked every time you add a new enemy into your collection. And what you get here is a newly generated view for this enemy. But here we use the create enemies view binding, which allows us to create an enemy view. And this is exactly what you get as an item right here. Now let's take a look what's going on under the hood. This method is used in the bind method of the Pinky Alien's game view base, a class which is strongly related to Pinky Alien's game view. And as you can see, we got this binding generated right here, and then a few other lines which are very interesting for us. Set add handler actually lets uFrame know what is going to be invoked when a new enemy is added. And set create handler lets the uFrame know how to generate the view for this enemy. So if you use the create enemies view binding, then you define it yourself. But what's going on if we don't specify those? If we navigate to set create handler method, we can see that it actually sets the given function as a non-create view property of this object. This one is used when collection changes. And as you can see, if we got any sort of create handler set up, then this is going to be executed, and the view will be equal to what your method invokes, or what your method returns actually. But if you don't specify any create handler, then internal stuff will be invoked to resolve this view for you, so you don't have to do anything. So absolutely the same applies for the add handler. This one sets up on add view property, which is again used when the collection changes and when your view gets generated using some sort of create algorithm, be it your stuff or internal. Then on add view is also checked, but it doesn't do anything if you don't specify a handler. And we know that uFrame is quite consistent. That's why you can find the remove handler as well, but it's hidden inside this remove lookup method. And as you can see, it's a bit tricky, and you should pay attention to this one, because if you don't specify a remove handler for your binding, then you're going to end up with your object being destroyed right away. This is something that may come in handy when you prototype your game, but I usually like to have more control over the things, and that's why I can use my enemies removed binding. One last thing that we want to know is how uFrame actually resolves the view when we don't specify a create handler. And I'm not going to dig into the code right now. I'm just going to show you an example and basically explain that every time uFrame tries to resolve the view, it takes the name of your element or your view model, like Pinky Aliens game. Then it refers to resources of your game and tries to find a prefab with the same name. So I can create resources folder here and put my prefabs inside this folder. Now uFrame is totally capable of finding those, because my platform is named after the element and my enemy prefab is named after the element as well. But we don't have Pinky Aliens game, so you have to either drop it directly into the scene, which we will do in a second, or you will have to override the create Pinky Aliens game view in another object which is going, to create this element in your scene. And yeah, then you can generate your view there. So I hope this explanation is more or less sufficient for now. So let's see if uFrame can actually do this for us. And since we removed the create enemy view binding, we have to modify our view file as well, because now it doesn't know what is a create enemies view method, and we can't override anything. So for now, we just suppose that this item right here will be exactly this game object from the resources called enemy. That's why we should apply the prefab here, so it actually get reflected in the prefab itself. When the enemy gets added, we can do whatever stuff we want, like placing them on the screen based on our rules. And yeah, this is up to us. When placing the enemies in the world, we will probably want to operate with the local positions, because they're going to be parented to some kind of a container. This is a common approach, and that's why uFrame goes ahead and tries to parent your newly created view to the enemies container, which is defined as a property here on the Pinky Aliens game view. So when going to the scene and creating a new game object, let's call this Pinky Aliens game, and let's draw Pinky Aliens game view. We will see that we got those enemies here in the bindings, and it allows us to set up a container. So why not? Let's create enemies container and set this as a container right here in the bindings. It also allows you to get all the enemies in the scene when your game loads or when your scene loads, and parent those to the container as well, and manage those by the binding. Also, pay attention to the enemy size. I'm going to assume that he is about 2 by 2 of built-in Unity metric system units, and I'm going to make a little spacing between them of about 1 unit. So this information will come in handy right now. Let's express this information as vectors, which will represent enemy size yeah, and spacing. So every time I add an enemy, I'm going to calculate his local X and Y coordinate based on how many enemies we have in the collection. And this one, this X right here is going to be his position in terms of the grid and not the Unity world. So we can just do Pinky Allen's game dot enemies count modulo Pinky Allen's game enemy rows. So this will just throw away all the previous rows and leave us with the X. Now Y is going to be an int, and this is going to be a result, oh my god, of dividing Pinky Allen's game enemies count by Pinky Allen's game enemy columns. Let me clean up the code a bit. Not something that I want really. So finally, let's sum up our spacing and enemy size, which could actually be cached, but who cares? And set that newly created enemy's view position or local position to new vector. Yeah, that should pretty much do the trick. Well, yeah, it's basically a very dumb grid which is aligned in the bottom left corner, I guess. Let's see if it works. Now here we got our Pinky Allen's game view, so we should initialize the view model and set enemy rows to 4 and enemy columns to 4. We will go into utilize the timer a bit later, and also we can set up a player view base. So we can do this right here. This is how uFrame allows you to set up parent, child view models for this Pinky Allen's game like a player. So the views will be synchronized, and also the underlying view models will be synchronized too, so this instance of the player will be actually a child of this Pinky Allen's game view model. If we hit play, we can directly send the command, And yeah, we got a few enemies generated. Kinda not perfect, but you see that they are all in the container. So nice. Oh yeah, I know why. Because we have to subtract 1 when actually counting the things. So now if we hit play, and hit start, we got a perfect grid of enemies generated. But I have a little bit too much of the spacing, and also I need to adjust this enemies container somehow. Let's put it right here, and let's decrease the spacing. And hit start. There we go. Coolio. So this tutorial is already quite long, so we will stop here right now, and in the next part we're going to make our enemies move, then we're going to make a big summary of what we currently have, and finally we're going to see how uFrame allows us to add effects to the game without touching the logic. And yeah, so you will see how useful it is to have the logic separated from the view. And thanks for watching. See you guys.